In example 19, for the vectors p and q, the components are given. We have to find in A the scalar product and in B the angle between the two vectors. So let's start with A. We have to find the scalar product and the components are given. So we have to use the second method again. So the scalar product of the vector p and q, this is the representation. This is how you write scalar product of vector p and q, is equal to, the components are given, so we do the x component of the first vector, 3, times the x component of the second vector, 2, plus the y component of the first vector times the y component of the second vector. So 3 times 2 is 6, 1 times minus 1 is minus 1, so that is equal to 5. So the scalar product of those two vectors is equal to 5. And then in B we have to find the angle between P and Q. And in the first method we learned that the scalar product of two vectors, of, for example, the vector P and Q, is equal to the magnitude of the vector P times the magnitude of the vector Q times the cosine of the angle between those two vectors. And that's the angle that we have to find. So we can move the P and the Q to the left hand side, so we find an expression for the cosine of theta. So the cosine of theta is equal to the scalar product of those two vectors divided by the magnitude of vector P times the magnitude of the vector Q. We know the numerator because we calculated that already in. So the numerator here, we already calculated in A, that is equal to 5. So the numerator is equal to 5. And in the denominator, the magnitude of vector P, we know the component, so that has to be equal to 3 squared plus 1 squared, and the square root of that, times the magnitude of vector Q is equal to 2 squared plus minus 1 squared. That is the magnitude of vector Q. So the cosine of theta is equal to 5 over the square root of 3 squared is 9, plus 1 squared is 1, so we have 9 plus 1, which is 10. So the square root of 10 times 2 squared is 4, minus 1 squared is 1, 4 plus 1 is 5, so we have the square root of 5 here. So 5 divided by the square root of 5 is just the square root of 5. So we have the square root of 5 over the square root of 10, which is equal to the square root of 5 over 10. We can simplify this again. So we have 1 over 2. So that is equal to the square root of 1 over 2, or 1 over the square root of 2. So the cosine of theta should be equal to 1 over the square root of 2. We know when that's possible. We draw the unit circle, the x-axis, and here the y-axis. 1 over square root of 2. 1 over 2 is here. Square root of 3 over 2 is here. And 1 over square root of 2 is here. So it's the middle one, and you know the middle one is the 45 degrees. We know that from chapter 21. So theta, the angle, should be equal to 45 degrees. Okay.